Welcome class to Chapter 2, Household Equilibrium. We're going to cover pages 8 through halfway through page 11. The topic that we're covering right now is budget constraints and budget lines. The budget constraint represents all the possible combinations of goods purchasable by the family if it uses all of its income in the period of analysis. For demonstration purposes, we are going to focus only on two goods, and we'll say we're going to look at food and all other goods. Equation 2.1 in your textbook says that the price of food times the quantity of food plus the price of everything else times the quantity of everything else exhausts a family's income. Definition: PF and PO are prices. QF and QO are quantities. And Y is income. We are going to use these variable names throughout the semester, so it behooves you to understand what they are from the beginning. This is a lot of variables to solve for if you think in terms of algebra. So we're going to say that some of these variables we know. Prices in our world are going to be given. So we will know what the price of food is and the price of other goods is. They're given. We're also going to know what the household's income is. That's given. The only thing we have to solve for is the quantity of food and the quantity of other goods. But even that's quite difficult in algebra because we're usually solving only for one x. So there's some tricks that we can use, and I hate to say tricks, but they're just mathematical things that we can do to make our life easier. And one of those things is shown in equation 2.2 in your text, which says the quantity of other goods maximum that you can purchase is income over the price of that good. All that says we're doing is setting the price and the quantity of food equal to 0. We can also say the maximum quantity of food that I could purchase is my income over the price of food. That would be setting the quantities and prices of all other goods equal to 0. Now these are just variable names and they're very general, but we can actually put numbers in to solve and make it more real life for you. Let's say that you have $40 this week to spend on food and all other goods. And the price of food is $8 a unit, and the price of all other goods is $4 a unit. How can we turn a general equation, such as the maximum quantity of other goods, into something that makes more sense? Well, we can say we know that the maximum quantity of other goods is equal to my income, which I'm now saying is 40, divided by the price of other goods, which I'm now saying is 4, and it says that if I only spent my money on other goods, I could buy 10 of them if I had no food. What if I spent all of my income, which is $40, on food, which is $8 a unit? That says if I only bought food and bought nothing else, I could buy 5 units of food. Going back, we say this is the budget constraint. The budget constraint is the price of food times the quantity of food plus the price of other goods times the quantity of other goods, and that exhausts all of my income. What I'd really like to do, though, is to be able to graph a budget line. So far, what we have is a budget constraint. So is there a way that I can say the price of food times the quantity of food plus the price of other goods times the quantity of other goods equals income, which is the budget constraint, and rearrange it into a budget line? Indeed, your textbook says that with a little bit of manipulation, which I'll show you in just a moment, I can say the quantity of other goods, which is going to be the good on my vertical axis, is equal to income over the price of other goods, minus PF over PO times the quantity of food. That is going to be the budget line. But how did I get from the budget constraint to the budget line? Well, let's go back and see if we can derive it. I want to get QO, or this number, this variable, all by itself. What can I do? The first thing I can do is I can divide everything by PO. And when I do that, I get PF over PO QF plus, this goes away, QO is equal to Y over PO. This is still troublesome. I want it all by itself. What if I subtract from both sides? This will go away, and I will get QO is equal to Y over PO minus PF over PO QF. And if I rearrange that just a little bit more, I'll get the quantity of other goods is equal to negative PF over PO QF plus Y over PO. What does this remind you of? Y equals mx plus b, where this y we're going to call r so we don't confuse it with income. But what you have right here is translated the budget constraint into a budget line. Let's move on and see how we might plot that budget line using what we have. And what we have is QO is equal to negative PF over PO QF plus Y over PO, or Y equals MX plus B. We're going to do this many times this semester. We'll put the quantity of food on the horizontal axis and the quantity of other goods on the vertical axis. We'll say, how can we plot this? Well, the easiest thing to plot right here would be the y-intercept, y over PO. And let's just say that's somewhere up there. Doesn't really matter now. Negative PF over PO is the slope of the line, QF is the quantity of food, and QO is the quantity of other goods. In order to plot a line, I need to have 2 points. How could I find a point on this axis, the QF axis, to identify where to connect the 2 dots to get a line? Well, I can go back to equation 2.3, which said the maximum quantity of food that I could buy was equal to Y over PF. Lo and behold, Y over PF will give me some unit right there. All I need is 2 points to graph a line. And that should be a straight line. Sorry about that, folks. What this budget line equation says, and the budget constraint says, that this household is able to purchase anywhere along this line if they exhausted their income, and anywhere inside this line to the origin if they didn't exhaust their income. These are the purchasing possibilities of this household. Everything underneath and touching the budget line. It also says that the slope of this line is negative PF over PO, or the ratio of the prices. To bring this alive a little bit, remember that we said income was $40. the price of food was $8 a unit, and the price of other goods was $4 a unit. Looking at this slope, negative PF over PO is 8 over 4 is equal to 2. It says that for every unit of other goods that I give up, I can buy half a unit of food. Or for every unit of food that I give up, I can buy 2 units of other goods. The slope of the line, or the rise or the run, is equal to 2. That's the trade-off between food and other goods that I want to purchase in the household. I can also go back to PF QF plus PO QO is equal to income, using $40 here and using $8 here and $4 here, figure out all the quantities of food and other goods that I could purchase along this line. I already know the axes, being the maximum quantity of other goods was equal to 10, and the maximum quantity of food was equal to 5. But I could also find the trade-offs between all of these things. So what if I said that I bought 2 units of food? That would be 16 plus 4 times sum QO is equal to 40. Or 40 minus 16 is equal to 4 QO. Or 24 is equal to 4 QO. QO is equal to 6. So that if I bought 2 units of food right here, that would correspond to 6 units of other goods right there. This is the basics that you need to do for us to move on. But it is the basics, so you need to understand what prices and quantities are and what the variables stand for. You need to know income. You need to understand how a budget constraint turns into a budget line. And you need to know how to graph a budget line. And that's where we'll stop today.